So we're about to go through and work through our practices. Woohoo! Nice! And as always, the more we practice, the better we get, and the more comfortable and prepared we'll be for what might lie ahead. Now remember, you are allowed to use a calculator on this test. However, I think this one is one that you don't need a very fancy calculator for. I don't even think I'm going to pull mine out, but it's okay to have one. You probably won't need much more than basic addition and multiplication. So basic calculator is fine. Scientific calculator is fine. Not a graphing calculator. Know the rules. Know the rules, follow the rules, and get success. And so it's going to be a fun test. We're going to be focusing on what? Systems of equations. And it's going to lead us to Gaussian elimination. We're solving. Gets us to matrices and things like matrix inverse. And then we're going to finish up with linear inequalities, systems of linear inequalities. And the final thing is integer programming. Lots of good stuff. Lots of good things to do. So we should begin. The first question on our practice, true or false? This is a practice exam, and as such, the questions will be different from what will appear on the actual exam. This is true, very true. So, this is a practice exam, and so keep that in mind. If you're trying to memorize specific answers, that's not going to go well for you. Learn processes. Learn how to solve the problems. You are capable. And you're going to see that really you're much better than you think. All right, well, now on to the real problems. Number 2. Solve by using substitution or elimination by addition. And so let's talk about these ideas. Now, what is substitution? Substitution says, hey, let me solve for one of the variables, put it in for the other one. So, for instance, how would a substitution solution look? Well, we could solve for, let's solve for 2y since they're both 2y. So I can swap the 2y and the 20, and that would give us 2y is equal to 5x minus 20. Now, put that in to our second equation. So we get 4x plus the 2i is replaced by 5x minus 20. So we're substituting in what we know. That's the idea of substitution, equals 34. Now we get one equation, one unknown. And specifically, we say, aha, 4x plus 5x is 9x. We can move the minus 20 across by adding 20, 54, or x equals 6. Now that you know x, we can get y. What do we say? Well, we plug it in. So we get that 2y is 5 times 6 minus 20. Well, 5 times 6 is 30. 30 minus 20 is 10. 2y equals 10. Y equals 5. All right. And so that's substitution. We're ready to answer. We said, look, we found an answer. X equals 6. Y equals 5. So it says, okay, select the correct choice below and fill in the answer within your choice. Now, it turns out we found one solution. And basically, there's 3 categories: 0, 1, or infinitely many. So we're in the 1, the unique solution. So our answer is A. And notice there's a box. We got to fill this in. And so we're going to put in an ordered pair. So when it says type an ordered pair, parenthesis, comma, parenthesis. And we go x, comma, y. So 6, comma, 5. And that's the answer. Okay, now, that's if we did substitution. Let's talk about elimination by addition. So that's another perfectly valid way to do this problem. And 5x minus 2y equals 20. 4x plus 2y equals 34. Now, the idea of addition here is we're going to add the 2 equations. Now, oftentimes we're going to scale in such a way that we get cancellation, but sometimes we're lucky and the stars align. And we say, well, hey, you know what? I think this is one of those times. Because if we just straight up add, we're not always going to be this lucky, but notice what happens. The two y's cancel. And we end up with 9x equals 54, or divide by 9, x equals 6. Now that you know x, plug it in. So we plug it into the first equation. 30 minus 2y equals 20. And you can move things around. That says 2y equals 10, or y equals 5. And again, we'll get the same answer. It's not about getting different answers. It's about getting to the answer in different ways. So that's what's going on. We have options. And I'm going to go ahead and tell you a secret. It probably can't tell which method you used, or if you used a completely different method. You know, it only knows whether or not you put the right answers. So use what you're comfortable with. And spoiler alert, you're going to have to do this kind of computation a lot. That is, solve a system of equations. So use what you're comfortable with. All right, well, that's number 2. On to number 3. Write the system of linear equations that is represented by the given augmented matrix. Assume that the variables are x1 and x2. All right, so instead of xy, x1, x2, that's perfectly fine. Just different symbol names. So it's an augmented matrix. Now, what does augmented matrix mean? Well, essentially says you have a series of numbers over here, then you have this vertical line and a column of numbers over there. That's the augmented part. It's been augmented by adding this column. And it goes on to say x1 represents the variable for the first column, x2 represents the variable for the second column. And it says, well, what's the equation that represents the first row? And what's the equation that represents the second row? Type equations using x1 and x2 as the variables, and type your answers in standard form. I'll talk about what standard form means in just a second. So here's the key. What's going on here? Well, what's going on is I'm going to rewrite this just to point out 3, 4, 5, 1, vertical line, 11, 7. And what we have is that these represent things. This vertical line represents equals. This column is associated with variables, in particular x1. This other column is associated with the variable x2. And then now these are just numbers. Now here's the thing. What's going on? Well, these are storing coefficients. So we can read 3x1 and 5x2 equals 11. All right, so 3x1 and this is the word plus 5x2 equals 11. Next one, 4x1 plus 1x2. Usually write that as x2 equals 7. And that's what you want to put in here. So the first row, these are your coefficients, 3x1 plus 5x2 equals 11. And the second row, 4x1 plus x2 equals 7. And that's it. We're done. Oh, smudging a little bit there. Sorry about that. Now, you might say, what did this part mean? Type your answers in standard form. Well, what's happening is that each one of these represents a line. And so there's a couple ways you can write a line. One is slope-intercept form, and that says, no, I don't want that. I specifically want standard form. So when it says standard form, it just means a times your first variable, b times your second variable equals constant. That's what standard form means. So that's what it's asking us to do. All right, and there we go. That's number 3. We're doing great. We're making record progress. Well, let's move on to number 4. Perform the row operation. Minus 2 row 2 plus row 1 goes to row 1 on the matrix below. So here's the matrix 3 minus 7, 2, 7 minus 4 minus 3. And they say, okay, here it is. Here's the operation. What's the new matrix? Okay, so let's make some notes here. What is this telling us? It's telling us we're going to make a new row 1, right? So row 1 is going to be changed. What does that tell us about row 2? Nothing happens to it. Pristine. So, with that in mind, we can copy whatever is not listed here, copy straight across. So we don't even have to do anything for row 2. So make sure if you don't do anything to a row, it just goes across. Life is good. Now we say, okay, that's great, but row 1 will change. How do we figure that out? Well, we follow the instructions. It says take -2 times the entry in row 2 and add it to the entry in row 1, and that becomes the new row 1. So, -2 times 7 is -14. Add that to 3, and what do you get? Well, -14 plus 3 is -11. Okay, -2 times -4 is 8. Add that to -7, 1. -2 times -3 is 6. Add that to 2, 8. And that's the result. Now you might say, well, wait, he didn't get like a 0 or something. Well, it's not testing us on that. That's later on. For right now, it's saying, do you know how to do row operations? And remember, there are 3 possible row operations. So be ready for all 3. You can do the following. You can swap 2 rows. So you could say, hey, I could swap row 1 and row 2. And if that had been the case, we would just literally swap row 1 and row 2. Okay, great. So we can handle that. You might say, oh, I can take a constant times row 2, and that becomes the new row 2. And that says, oh, row 2 is changed by scaling, but row 1, nothing happens, copied across, and then everything on row 2 gets scaled up by a factor of c. But I will say, amongst all the row operations, this particular form is the most important and the one you should get very comfortable with, because it's also the one that's not like immediately obvious. So it's scaling one of the rows by a constant, adding it to the other row, but you leave the row 2 as is. Only row 1 gets updated. And that's actually a good way to think of this arrow. You say, okay, combine -2 times row 2 plus row 1, and now use that output to update row 1, or to replace row 1. There's a couple ways you can say it. But that's the idea. That's wonderful. All right, on to number 5. Use row operations to change the matrix to reduced form. Okay, so it'll help if we know what reduced form is. So what is reduced form? Well, reduced form has a couple of requirements. Essentially, it says, I want to make sure the first entry that's non-zero is a 1. Okay, great. If I have a first entry that's a 1, everything else in that column has to be knocked out. Everything else is a 0. Okay, great. And the third thing is my 1s that are the first ones keep moving to the right as I go down. That's reduced form, right? That's what we're shooting for. So as we look at this, we say, okay, well, in the first column, we're looking great, right? Because we see a 1 right away. We've knocked out everything else. Beautiful. So we say, okay, that's doing what it needs to do. And we say, all right, well, let's go to that second column. And we say, we have a 1 right away. And those have been used to knock out the other entries, and those are zeros. Perfect. And so then we say, okay, now we come to that third column. Say, we want that to be a 1. And we're like, no. Okay, so now that means there's work for us to do. So we say, all right, well, let's get to work. So what can we do? Well, step 1, make it a 1. So how do we make it a 1? Well, what we'll do is we're going to scale. So we're going to take 1/4 times row 3 and use that to become the new row 3. So in other words, we're multiplying everything by a fourth. It leaves the first two rows alone. So we still have the 1, 0, 3, 4. We have the 0, 1, minus 2, minus 5. And then we have the 0, 0. 4 times the fourth is 1. Negative 12 times the fourth is negative 3. All right. Good. Now we like that 1. What don't we like? Well, what we don't like are these pieces here. We want those to be zeros. In particular, since we've learned a lot of terminology, you can think of the goal in reduced form is try to make this part look like the identity. That's really what the goal is. And if you can't, well, it is what it is. All right, well, we can do it in a couple rounds. We'll go ahead and do it in 2 rounds. I'm going to use row 3 to help knock out that entry in row 2. So I'm going to put a little 2 on the side just to help me remember. I'm going to multiply row 3 by 2 and add up. 2 plus negative 2 makes 0. So in terms of our notation, 2 row 3 plus row 2, that's going to become our new row 2. So doing that, what will we get? Well, we're not touching the first row. We're not touching the last row. The only thing that's being affected is row 2, because that's the one that's being updated. So 2 row 3 plus row 2, 0 plus 0, 0. 0 plus 1, 1. 2 plus negative 2, 0. Negative 6 plus negative 5, negative 11. All right, good, good. Now, we got to knock out that 3. Okay, sure, we can do that. What do? Well, same thing as we just did. We're going to use the last row and say what? Well, I'm going to multiply here by negative 3. And in particular, negative 3 times row 3 plus row 1 becomes the new row 1. Why? Because negative 3 plus 3, 0. All right, so we get the last 2 rows are as is. Good. Now, 0 plus 1, 1. 0 plus 0, 0. Minus 3 plus 3, 0. Now, minus 3 times minus 3 is 9. Plus 4 makes 13. Oh my goodness. Whew, what a number. But there we go. This is the reduced form. Right? We have, if it looks like the identity, that's reduced form. But otherwise, you say, make sure the leading non-zero terms are 1s. Everything in those columns other than those 1s are 0s. And your 1s move to the right as you go down. So now we just have to put it in. And we put it in 1 entry at a time. And but you kind of know what's going to happen, right? The thing to the left of the dividing line should, knock on wood, or whatever, if you have wood, I don't have wood right next to me, should look like the identity. And mostly it's just a matter of what are these numbers. In our case, 13 minus 11 minus 3. And I'll go ahead and say it right now. I think one of the hardest things about this exam is going to be copying errors. It's going to be so easy to make a small copy error. And that copy error will just, it'll cascade. So it doesn't hurt to double check, did you copy things right? And it looks like we copied it faithfully, so that's good news for us. Let's move on to number 6. Use the Gaussian elimination method to find all solutions of the systems of equations. And like, oh my goodness, wow. So here's our systems of equations, and it says write the system of equations as an augmented matrix. Okay, so let's just go ahead and do that. Now, it gave us some hints. See how there's a 3 here and a minus 12 here? that 3 is helping us recognize, oh, that is going to be that 3x1. And so in particular, what they're trying to tell us is that the first column is the x1 column. The second column then must be the x2 column. And over here we have the numbers. Okay, so that's what we have. And now this 3 also tells us the first equation goes here. This minus 12 tells us the last equation goes there. And so we can read off the coefficients. So you can think of this as being the x1 coefficients. Now, if one of the equations doesn't have an x1, that would be a 0 entry. This is the x2 coefficients, the x2 columns. So again, put down the x2 terms. Don't forget about minuses. Those are important, so plus or minus. And then here you've got your constants. -1, 37, and -12. All right, lots of things to do here. So it says solve the system. Now it says use Gaussian elimination, so we'll go ahead and do that. Any method that you're comfortable with, you get full credit on. No worries. And then, so we're going to solve, and then we're going to see what's going on. It says select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. We may have a unique solution, a system with infinitely many solutions, or no solutions. So let's find out. Okay, so what do we do? Well, let's just think about ways to simplify things. Notice this last equation, everything has a factor of 6. So let's go ahead and scale this last equation by 1/6. So 1/6 row 3, that's become our new row 3. 1, 1, -2. Okay, that's going to help things a lot. That's good. So updating as we go along. So I'm just copying the other first 2 rows. And now what can we do? Well, we can help knock stuff out. So for instance, what can we knock out? Well, let's suppose we knock out, let's use this one to our advantage. So that we can do by swapping. We'll go ahead, since we already have a 1, let's go ahead and put it at the top. So I'm just going to swap the first and the third row. That's our Gauss-Jordan, one of our rules we can do. So this is our swap row 1 with row 3. And now I'm going to go ahead and do 2 things at once. Multiply by -4 times the first row added to the second, and multiply by -3 times the first row and add it to the third. In other words, knock stuff out. We like to do that. So our notation here, -3 row 1 plus row 3 becomes our new row 3. -4 row 1 plus row 2 becomes our new row 2. And if we do all of that, what will we have? We'll have the following. We'll get the row 1 stays as is. Okay, so -4 plus 4, 0. -4 plus -5, -9. And here it's 8 plus 37, 45. And okay, now -3 plus 3, 0. -3 plus 2, -1. And then here we have 6, right? -3 times -2 is 6, plus a -1 makes that 5. And say, well, this is pretty good. What can we do here? Well, we have a couple of things, right? Keep in mind, there's a little bit of choose your own adventure. The important thing is at the end, you'll get what you need. Let's do some swapping. Well, actually, let's go ahead and do this. We'll multiply this middle row by -1/9, and we'll multiply this bottom row by -1. So if we use our notation, not that we have to while we're taking the test, but just in case you're wondering, like, wait, what is he doing? So that's what's going on. we'll get 1, 1, minus 2, 0, 1, minus 5, 0, 1, minus 5. You might say, aha, we have a duplicate row. Isn't that bad? No, actually, that's okay. Duplicate rows are okay. That's not a problem. In fact, what's going to happen? Well, we're going to do minus 1 times the second row, add it down. And then we'll do minus 1 times the second row and add it up. And if we do that, so minus row 2 plus row 1 becomes row 1, minus row 2 plus row 3 becomes row 3. That's the operation. We're going to get the following. And we'll have it in reduced form. And I'm doing that just because I'm following the instructions. Quite frankly, again, if you didn't follow the instructions, you'd probably be getting the same answer. And you'd get the same points. Use whatever you like. But this is just for practice, so it's good to practice. We get in the middle 0, 1, minus 5. Down below we get 0, minus 1 plus 1, 0, 5 plus minus 5, 0. This is okay. We'll come back to that. In the first row, 0 plus 1 is 1, minus 1 plus 1 is 0. Here we have 5, right, minus 1 times minus 5, plus negative 2 is 3. Now, the last equation, all zeros says 0 equals 0. That's okay. So we'll make a little note. This is okay. If we had gone 0, 0, 1, right, this is bad. That is the there is no solution situation. And because that reduces to 0 equals 1, this is 0 equals 0. All right. So what do we have? Well, we have one solution. One solution to rule them all. We can read it off. Because remember, this is the x1. Here's x2. This says x1 plus 0x2 equals 3. So we can write here x1 is 3. And this says 0x1 plus 1x2, which is just saying x2 is negative 5. So x2 is negative 5. Now you might say, can we check our answer? Yes! On a surprisingly large amount of this test, you can check your answer. Because what can you do? You say, well, let me plug these in. 9 minus 10, negative 1. Good. 12 plus 25 is 37. Great. 18 minus 30 is negative 12. So if you want to check if you got the answer right, go back and say, hey, this is what I think should be a solution, and check it out. And if it is, you're getting the points. Woohoo! Party for everyone. That's what we want. We want to get all the points. All right. So, I should probably mark that we went with option A. I've done that before, right? I think I've kept marking them. My apologies. I'm going to just double check. Yep, we're good. We're good. Okay, which means number 7. Use Gaussian elimination, which is another way of Gauss-Jordan elimination, to find the complete solution to the following system of equations, or show that none exist. I'm pretty sure that's a typo. I'm pretty sure they meant to write none exist. But, well, we're amongst friends. We know what they mean. So, 7x plus 11y plus 8z equals 14. 3x plus 5y plus z equals 4. X plus y plus 6z equals 7. All right, so we have 3 equations, 3 unknowns. Select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. Now, there's a couple of things that could happen. We could get a unique solution, which is option A. We could have infinitely many solutions, but have what's called 1 degree of freedom, which means that essentially there's one choice we get to make, and then you can make x3 your free choice, and x1 and x2 are arbitrary. Or we could have 2 degrees of freedom, which would say x1, well, x2 and x3 are free choices, and x1 is dependent on the other 2, or there could be no solution. And it's really rare to have this happen. About the only way you can have this happen is basically have the same equation written down 3 times. And that rarely happens. At least it rarely happens intentionally, unintentionally. Okay, so how do we proceed? Well, Gaussian elimination. Okay, so how do we do that? We can do it using turn things into an augmented matrix and work from there. We could just work with the equations themselves. I'll go ahead and write it into an augmented matrix just so we can get more practice with that. 7, 11, 8, 14, 3, 5, 1, 4, 1, 1, 6, 7. Now, I like the fact that there's a 1 here, so I'm going to swap the first and the third rows. So row 1 is being swapped with row 3. Okay, so if we do that, we'll get 1, 1, 6, 7. The 3, 5, 1, 4. And the 7, 11, 8, 14. Okay, now let's knock out some terms in the first column. So I'll switch colors here as we switch operations. We're going to take the first row and say, if I multiply it by -3 and add down, then hey, that'll knock out what I needed. And similar, if I multiply the first row by -7, add to the third row, I'll get rid of what I need. So -3 row 1 plus row 2 becomes our new row 2, -7 row 1 plus row 3 becomes our new row 3. So that's what we're doing. That's the notation for the operation going on. 1, 1, 6, 7. All right, so -3 row 1, add down. -3 plus 3, 0. -3 plus 5, 2. -18. Okay, all right. It's -17. Sure. -21 plus 4. It's -17. Oh my goodness. Wow. Well, numbers are what the numbers are. What can you do? All right, now let's do the next one. -7, add down. -7 plus 7, 0. -7 plus 11, 4. -42 plus 8. If you need to grab a calculator, that's okay. I happen to know that's -34. And then -49 plus 14. -49 plus 14 is -35. But again, if you want to grab a calculator, nothing wrong with that. Okay, and now we look at that and say, oh, well, this is interesting. These numbers are lining up really well. Let's notice how 2 and -17, 4 and -34. Let's go ahead and multiply here by -2 and add down. Right, we don't have to make that a 1 right away. One of the things about Gaussian elimination says, hey, you have choices. You know where you're going. Just sort of work on getting there. And so we have 0, 2, -17, -17. 0 and 0 makes 0. -4 plus 4, 0. And by the way, I didn't write this down, but we're taking -2 row 2 plus row 3 becomes our new row 3. 34 -34 becomes 0. And here we have 34 minus 35 becomes -1. Now, this should make you stop. If you ever have this, you stop. Don't keep going. Because what does this equation tell you? In fact, we mentioned it just on the last problem. And we said, it's a problem if you see this. What does it say? 0x plus 0y plus 0z, which means that the left-hand side means 0. The line means equals -1. That can't happen. So, what does that mean? That means no solution. So, the good news is we can stop. As soon as you get to this point, you can stop. Now, you may not have gotten there. You may have actually found a unique solution. Or you may have found more than one solution. But here we're like, okay, there is no solution. So the answer here was D. We don't have to fill anything in. So, all right. Well, we'll be ready, right? Because that might be a possible answer. All right. Well, that brings us to number 8. Perform the indicated operation, if possible, and then select the correct choice below, and if necessary, fill in the answer box to complete your choice. Now, the two options are, there's an answer. Now, there's supposed to be a box here, but couldn't quite fit that in. And then the operation is not possible. Let's check to see if the operation is possible. So to check that, check the sizes. What do we have? We have a 2 by 2, and then we have a 2 by 2. And here's the check. If you're multiplying matrices together, the inner pieces have to match. If the inner pieces match, you are good. Multiplication can happen. If they don't match, you're out. Now that's for multiplication. For addition or subtraction, what needs to be true, the sizes have to match. And so, in other words, the whole thing would have to match. But okay, we know it's not B because we saw that those match. Now we have to remember how matrix multiplication works. And unfortunately, it's not the easy, obvious thing. Easy, obvious thing? Multiply the entries. Like, -3 and -8 and -30 and 14. And we're done. But here's what you do. We're going to work with the rows from the first matrix. And we're going to work with the columns of the second matrix. So I'm marking the rows and the columns. And now you proceed in the following fashion. I have the output 2 rows, 2 columns. And I'm going to combine every possible row with every possible column. So if we want the first row, first column entry, first row, first column, what we do is we multiply all the pieces but then add them up. Right? We're going to work our way across and down simultaneously. 3 times -1 is -3. -2 times -6 is 12. -3 plus 12 makes 9. First row, second column. First row, second column. 3 times 4 is 12. -2 times 2 is -4. 12 minus 4, 8. Okay, second row, first column. Right, second row, first column. 5 times -1, -5. 7 times -6, -42. -5 minus 42, you can use your calculator. It's -47. You can get some big numbers. Multiplication, things get big. Second row, second column. Second row, second column. 5 times 4, 20. 7 times 2, 14. 20 plus 14, 34. So we know that multiplication is possible. So our selection, of course, is A. And then we can fill in with the 2 by 2 matrix that results. So just remember, check to see if the sizes match. Then you're going to combine rows and columns. And that you're going to multiply along a row, down a column simultaneously. Multiply and add the pieces up. And that gives you one entry. And you do it over and over and over till you get all the entries accounted for. And that's the problem. All right, that's not so bad. On to number 9. Given the following matrices, perform the indicated operation if possible. So we have an A, B, C, D. What's the indicated operation? B plus AD. Well, this could be bad. Okay, all right. Come on, get out of here. Let's see if this is going to be possible. Either B plus AD is something, and we'll have to figure it out, or the matrix product is not defined. Those were our two options given. Okay, so what's going on? Well, let's talk about sizes. So I'm going to work over here. So B is a 2 by 2. Okay. And then we have A, which is 2 by 3, right? Number of rows, number of columns. 2 by 3. And then we have D, 3 by 2. So this is a 3 by 2. So what's going to happen? Well, check. Do the insides match? Yes. 3's match. So what's going to happen is when you multiply A times D together, the result will be the outside pieces. This is going to be a 2 by 2. So we're going to have a 2 by 2 plus a 2 by 2. Now, the important thing is that when you add, they have to be the same size, and they are. So we know we'll get something out. So, okay, so it's not B. So that means we have to figure it out. So as we said, it's a 2 by 2. So, all right, we put our 2 by 2 there. And let's start by working on AD. So we're going to put those right next to each other. So we can just reference that. So we have our A times D. So we're going to copy. And be careful. More order matters in multiplication. So if you say, oh, let me take D times A. No. No, 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 no. It's whatever it tells you to, exactly in that order for multiplication. Okay, so we're copying it down. 6 minus 2, 5. Minus 3, 8. Minus 5. And now D, 3 minus 1. Minus 5, 6. 2 minus 4. And there is our matrices. AD. And as before, what are we going to do? Well, we're going to work with the the rows of the first, the columns of the second. Okay? That's the key. Rows of the first, columns of the second. So, we proceed term by term. Here we go. I want the first row, first column. So we're going to work our way across the first row and down the first column. 6 times 3, and that's 18. Minus 2 times minus 5, plus 10. And 2 times 5, another plus 10. And add that up, that makes 38. So that's the first entry. All right, it doesn't hurt to do scratch work. Next entry. 6 times minus 1 is minus 6. Minus 2 times 6, minus 12. 5 times minus 4 is minus 20. Well, that's minus 18 minus 20. That's minus 38. It's just a coincidence. All right, don't read too much into that. Minus 3 times 3, minus 9. 8 times minus 5, minus 40. Very negative, this one. 2 times minus 5 is minus 10. And, okay, so what does that give us? Minus 59. Okay, minus 59. All right, second row, second column. We're almost there. Minus 3 times minus 1, plus 3. 6 times 8, 48. And minus 5 times minus 4 is a 20. Okay, 3 plus 48 is 51, plus 20 makes 71. And there we go. Good. Is that our answer? No, that's our AD. So what do we need to do? Well, we take B, which is 1 minus 4, 2, 6, and add that to 38, minus 59, 71. So for addition, entry by entry. 1 plus 38, 39. Minus 4, subtract 38, minus 42. 2, subtract 59, minus 57. 6 plus 71, 77. And that's it. We'll mark A as being correct, and that is the answer we put into our box. But we really didn't have much of a box, so we'll add a box. There we go. All right. So carry out the procedure and just patiently work it through. This is one that has a couple of things. You got the multiplication, you got the addition, and just slowly take your time. And then you'll be great. All right, on to our next problem. Number 10. Find the inverse of the given matrix if it exists. Okay, and so we have select the correct choice below, and if necessary, fill in the answer box to complete your choice. There's a big box here, but I didn't have time to draw it. It says type an integral. I'm pretty sure they meant integer. Typo, sorry about that. Or a simplified fraction for each matrix element. So that's if the inverse exists, and B, the matrix inverse does not exist. Now, I'm going to go ahead and say that if you're trying to find the inverse of a matrix, it's going to take a little bit of work if it's 3 by 3. I know coming up there's going to be a chance for us to do it 2 by 2, so I'm not going to talk about that, because that we have a little shortcut. For 3 by 3, you're going to work. And so in the interest of having space, I brought some extra paper. Not a bad idea to have scratch paper. Maybe a couple pages, because you're going to want to write stuff down. So, what's the procedure? Here's the basic rule. We'll write it down right next to it. You're going to start by making an augmented matrix. You put your matrix, your dividing line, and then you put the identity matrix, and then you do your Gauss-Jordan. So this is GJ, Gauss-Jordan. And now, if you get I, then what you have on the right is the inverse. If you can't get I, there is no inverse. So, that's the plan. Not a bad plan. The only problem is there's a lot of things that could happen along the way. So, let's begin. We start by writing down our matrix. 3, 1, 2, 1, 4, minus 1, 2, 3, 0. Put our augmented part here. Add the identity. And identity means there's zeros except along this diagonal. Now perform your row operations. And we get some freedom. So work column by column to do row operations. So I want to start with the first column. And I say, well, I want this. My goal is to say, make this a 1, 0, 0. This is our secret goal for this column. You say, well, we already got a 1 there. Great, let's take advantage of that. We'll do a quick swap. So I'm going to swap the first and the second row. And so that's 1, 4, minus 1, 0, 1, 0, 3, 1, 2, 1, 0, 0, and 2, 3, 0, 0, 0, 1. All right. So I did a quick swap. Now I have a 1 in the right place. That makes me happy. This is a good progress. What do we need to do next? Well, we need to make these terms zeros. Okay, so that's our next goal. So let's do it. So I'm going to write here on the side minus 3 to indicate minus 3 row 1. Add that to row 2. And similar, minus 2 row 1, add that to row 3. Doing that, the first row stays as is, which is good. The second row, well, we're multiplying by negative 3 and adding down. So we get negative 3 plus 3, 0. Negative 12, plus 1, negative 11. 3 plus 2, 5. And then we get 0 plus 1, negative 3 plus 0, negative 3, and 0 plus 0. Not the greatest numbers there, but, I'll be honest with you. Inverses can get messy. And finding inverses, you just got to work the process. Trust the process. And take your time. Small mistakes can snowball. Minus 2 plus 2, 0. Minus 8 plus 3, minus 5. Here it's 2 plus 0, 2. 0 plus 0, 0. Minus 2 plus 0, minus 2. 0 plus 1 is 1. All right. Now, we come to our second column. We say, all right, what do we need to do? Well, we need to make a 1. Well, which term do we make a 1? Well, either term will get us to fractions. The question is, are we more comfortable with 1 over 11 or with 1 over 5s? And that doesn't mean we're going to end up with 1 over 11s and 1 over 5s. It just means we're going to have fractions along the way. Okay, well, I'm just going to go ahead and metaphorically bite the bullet. And let's scale this middle one. Oh, wait. I did not copy correctly. I saw this column of zeros, like, that can't be a column of zeros. And this is, I even said this, it's going to be copy errors. We'll get to the end and then we'll check our answer. I'm fingers crossed we get it right the first try. All right. Because oftentimes this problem will probably be the most time-consuming problem. I'm going to go ahead and say it right now. You will spend more time on this problem than any other problem. So it's okay to save this one to the end. Get all the points you can. Don't get stuck on a problem that takes a lot of time, but you're not going to get a lot of points off of. Okay, now we have success in the first column. I should have said, and now we move to the second column. Our goal now is to make this a 0, 1, 0. And we say, okay, well, we're not going to make this 4 into a 1 because this has already been taken care of, so I can't do much with that. So that's why you have to make one of these to be a 1, which is why I said, okay, we're going to just multiply this row by negative 1/11 and live with what that entails. So we have 1, 4, minus 1, 0, 1, 0, 0, 1. So everything in the middle row gets changed. Factoring in a factor of 1/11. So minus 5 over 11, minus 1 over 11, 3 over 11, and 0. And the bottom row, that's, we'll go ahead and keep that as is for the time being. Okay. All right. Good. And I'm just double checking. It doesn't hurt to double check things. Just want to make sure I didn't make any silly copy mistakes yet. Because that would be silly. And you don't want to make mistakes at the beginning. You don't want to make any mistakes. But you don't want to make mistakes at the beginning. All right. Now we're going to use this row with this one to knock out the others. So in particular, the 4 and the minus 5, I want those gone. All right. Well, with that in mind, what's going to happen? We're going to multiply by negative 4. Second row, add it to the first row. Multiply by 5. Second row, add it to the third row. The second row, it is still what it is. No worries. Now is not the time to panic. That comes later. All right. Let's start on the first row. 0 plus 1, 1. Negative 4 plus 4, 0. 20 over 11, right? Because that's negative 4 times negative 5 is 20 over 11. 20 over 11 minus 1. Well, that's going to be 9 over 11. Because minus 1 makes minus 11 over 11. Then we're going to get 4 over 11. Here we get minus 12 over 11 plus 1. Well, that's 11 over 11, so that's minus 1 over 11. And 0 plus 0. All right, good. Now, what's happening here? Well, we're going to add down. 0 plus 0, 0. 5 plus negative 5, 0. Minus 25 over 11 plus 2. That's like 22 over 11. So minus 25 over 11 plus 22 over 11 makes minus 3 over 11. All right, good. And then we have minus 5 over 11. Okay, so add that down, minus 5 over 11. 15 over 11 minus 2. So that's 15 over 11 minus 22 over 11. And 15 minus 22 makes it a minus 7 over 11. And then 0 plus 1, 1. All right, good, good. Now, 2 columns down. That means we're 2/3 the way there. In the last column, there's not much that you do. The last column says, look, you got to make this entry into a 1 and say, okay, well, the only way we can do that is we scale. So we're going to scale this entry by what? Well, minus 11 over 3. Now, when I scale that entry, I'm really scaling the whole row. So where are we at? Well, the first two stay as is. All right. And so copy down carefully and methodically. And 0, 0, minus 11/3 times minus 3/11 is 1, right? Multiplied by the reciprocal. Here, minus 11/3 times minus 5/11. The 11s cancel, the minuses cancel, so we're left with 5/3. The next term, the 11s cancel, the minuses cancel, we're left with 7/3. And then finally on our last term, 1 times minus 11 over 3 is minus 11/3. Good, good. Okay, now, what are we going to do? Well, again, our process says to do the following. We're going to use that 1 to knock out these other terms. Okay, so there's a methodicalness to it. And so it's not super exciting, but the good news is it's super predictable. We can follow the process through. So we say, okay, we're going to times it by 5 over 11 added to the second row. And then we're going to times it by negative 9 over 11 and add it to the third row. And then we're going to be really patient with ourselves while we clean this all up. Okay, so here we go. The bottom row is what it is. 5/3, 7/3, minus 11/3. Let's do the middle row. 0 plus 0, 0. 0 plus 1, 1. 5 over 11 plus negative 5 over 11, 0. So it's 0, 1, 0. All right, now, here comes the part where we have to take our time. We have 5 over 3 times 5 over 11. That's going to give us what? 25 over 33. Subtract 1 over 11. Right? Multiply and add. Well, that's the same as what? That's 25 over 33 minus 3 over 33. Yes? It is. Which is 22 over 33, which, notice, they both have factors of 11. That makes 2 over 3. So, 2 over 3. Okay, next. 7/3 times 5 over 11. That's 35 over 33. Add 3 over 11. Well, okay, that's 35 over 33 plus 9 over 33, get a common denominator, which makes 35 plus 9 is 44 over 33, also known as 4/3. So that's 4/3. Okay, cool. Now what? Well, 5 over 11 times minus 11 over 3. Well, notice the 11's cancel, so you get minus 5 over 3. And we're going to add 0. Okay, well, don't have to do much. That's negative 5 over 3. So that goes here, negative 5 over 3. All right, 2 rows down, 1 row to go. We're almost there. Okay, first row, 0 plus 1, 1. 0 plus 0, 0. Negative 9 elevenths plus 9 elevenths makes 0. Yes. Okay, so let's now carefully work this out. We have minus 45 over 33, right? That's these terms. Add 4 over 11. Well, that's minus 45 over 33 plus, multiplied by 3 over 3, 12 over 33, which makes negative 33 over 33, also known as negative 1. So, negative 1. All right, and then next term, we're going to take 7/3 times minus 9 elevenths, and if we do that, we get, well, actually, we get something that really nice happening. We should point this out. The 3 and the 9, that's going to play to our advantage. We should take advantage of that. So if we do that, 7/3 times negative 9 elevenths. We'll do this here, and then we're going to add a minus 1 over 11. Right? 7/3 times minus 9 11 plus negative 1 over 11. The thing we can take advantage of, which I didn't in the last one, I feel silly. You can cancel a 3. So this really becomes what? This becomes a minus 21 over 11 minus 1 over 11, which is minus 22 over 11, which is negative 2. So, negative 2. And our last one, which is going to be really easy because we're going to add to 0, minus 11/3 times minus 9 elevenths. And here, add 0. Well, the 11's cancel, the negatives cancel, 3 goes into 9, leaving us with 3. So, our last piece is 3. All right, so here's the claim. Here's the claim. We started with M, right? We worked until we made this left-hand side look like I. This is the inverse. Now, that's a bold claim. Can we check it? Yes. Yes. And if you've gone this far and you're still hanging out with me, I appreciate you doing that on this problem. There's a way to check. And as the great philosophers have said, you should check yourself. So here's how you check yourself. Start with your original matrix. M. Multiply it by what you think the inverse is. And what should happen? Well, you should get I. If you get I, you did it correctly. If you don't get I, you didn't do it correctly, and you need to check your work. So here we go. We get minus 3 plus 2/3 plus 10/3. 2/3 plus 10/3 is 12/3, which is 4. Minus 3 gives us 1. Okay, so that's first row, first column. Minus 6. Minus 6 plus 4/3 plus 14/3. 4/3 plus 14/3 is 18/3, which is 6. Minus 6 is 0. minus 9, minus 5 thirds, and then minus 22 thirds. Well, minus 5 minus 22 is minus 27. Divided by 3 is negative 9. And then, I copied it down wrong. That should have been a plus 3. So it's 9, subtract 9, which is 0. Okay. Phew. All that work, and I was like, when I checked it, I didn't copy it right. Oh my gosh. Okay, so so far we're good. Minus 1, 8 thirds, and minus 5 thirds. Well, 8 thirds minus 5 thirds is 3 thirds, which is 1. Minus 1 makes 0. Minus 2, 16 thirds minus 7 thirds. So 16 thirds minus 7 thirds would be 9 thirds, which is 3. 3 minus 2, 1. 3 minus 20 thirds, and then plus 11 thirds. Minus 20 thirds plus 11 thirds is negative 9 thirds, which is negative 3. Add 3, 0. This is good. Minus 2 plus 2 plus 0. Good. Minus 4 plus 4 plus 0. Good. 6 minus 5 plus 0 is 1. So, if you multiply the original matrix times what you think is the inverse, and you get out the identity matrix, then you 100% know you did it right. So now, we don't have to know whether or not we're going to get full credit. We know we're getting full credit. We just have to copy it correctly. So minus 1, minus 2, 3, 2 thirds, 4 thirds, minus 5 thirds, 5 thirds, 7 thirds, minus 11 thirds. All right, just double check. Make sure you copy it correctly, and all the pieces are there. Every entry has to be either an integer or simplified fraction. Simplified fraction means what? No common factors, right? We couldn't have written this as minus 6 thirds. No, it needs to be minus 2, because that's not a simplified fraction. And the last thing we should do is we should mark it. It says, hey, this has an inverse. All right, now that we've used up half our time, again, if you're asked to find an inverse of a 3 by 3, honestly, I encourage you to maybe skip and come back to it. Use your time wisely. If it's worth 1 point, there's better ways to spend your time. All right. So, number 11. Write the matrix equation as a system of linear equations without matrices. And so now this gets back to basically what you were doing before. One of the easiest things to do is just carry out the multiplication. So if we carry out the multiplication, this becomes minus 5x plus 6y plus z. So right, minus 5x plus 6y plus z. Okay. Equals, and this side 2, 3, minus 5. And now the next entry, 4x plus y plus 0z. So that would be 4x plus y. Last one, 7x minus 5y minus 3z. Okay, great. Now, what do? Well, you just say, look, equation 1, equation 2, equation 3. So the answer is, we compare the entries. Minus 5x plus 6y plus z equals 2. 4x plus y equals 3. 7x minus 5y minus 3z is negative 5. And to think we get as many points for this problem as finding the inverse of a 3 by 3. What a world. All right. Number 12. Find x1 and x2. So there's lots of ways to do this. You can, if you want, say, oh, let me rewrite this. This is the same as 2x1 minus 3x2 equals 23, and 4x1 plus x2 equals 11, and then solve. Because you have a lot of ways to do that. However, I want to do it in the spirit of what the problem wanted you to do. So what did this problem say? Well, it says, here's this matrix, let's call it A. Here's something x, it's our variables, and that equals b. So we have a times x equals b. And we say, well, I just want to move the a across. So we say, okay, so we do that by multiplying both sides on the left hand by a inverse. So we get x equals a inverse b. So if we can do this computation, it's really quick. Now the good news is 2 by 2s are faster to find inverses, and you can do it just as we found a 3 by 3, but there's even another way to do it which is really slick, and I just want to point that out. So if you're comfortable with it, here's how you do it. If you have a 2 by 2 matrix, A, B, C, D, and you want to find the inverse, it's 1 over, you multiply diagonals, AD, subtract BC, and then you swap the main diagonals and you change the side on the off diagonals. And that's it. That's the inverse. So according to this, it's 1 over 2 subtract minus 12. Okay? Down, subtract up. Swap the diagonals, flip the signs on the off diagonals. And you can carry out and check what happens if you multiply these two together and then divide by 14, because that's what you have there, is you have 14. And if you do that, you get what you need. You can always check. In the interest of time, I won't check it here, but like I said, if you don't like this, solve it any way you want, because it will never know what you solved, how you approached it. I'm just doing it this way just to show you it's an option. All right, so what do we have? Well, we have 1 over 14, and now carry out the multiplication. So we have our 2 rows, but we just have the 1 column. So we say, okay, that would be 23 plus 33, right? 23 plus 33, 56. Minus 96, minus 92, excuse me, plus 22. Minus 92 plus 22 minus 70. Multiply by 1 over 14. 56 over 14 is 4. Negative 70 over 14 is negative 5. So that is x. Well, what is x? That's x1, x2. So now we can read off. x1 is 4. x2 is negative 5. And we're done. Again, you could solve it with any system that you want, any way that you want. Do what works for you. You're here for the points. And because it doesn't specify, and because it can't check what you actually do in the middle, it'll never know. What's important is that you get the right answer. You get the points that you came for. And we want you to do well and succeed. All right, now this up to now has been chapter 4. We're going to transition to the next chapter, chapter 5. So we have a few problems left, but they deal with other material. All right, here we go. State the linear inequality whose graph is given in the figure. Write the boundary line equation in the form ax plus by equals c with a, b, and c integers before stating the inequality. So they gave us the picture, and I will say I was not very good at marking things, but the thicker line, those are your axes, and the grid count. So here is 3, here is 4. But the point here is we don't have to do much work because we see what it is. It's 4x plus 3y and 12. All we have to figure out is which one of these 4 inequalities do we use. So we're looking for 2 clues. First off, you have to look a little closely and say, is this a solid or a dotted line? Now, I don't know the resolution, but this is a dotted line. So when you see a dotted or dashed line, what does that mean? That means it's one of either less than or greater than. A solid line, what does that mean? Well, that means we include it, so it's less than or equal or greater than or equal. Because it's not a solid line, we can knock out A and D. So now we're down to a 50-50 chance. So, well, how do we know? Well, now we have to know which side to shade. So pick a convenient point. 0, 0 is super convenient if it's available. But you have lots of points. And you say, okay, here's 0, 0. And test it. Is 0 plus 0 bigger than 12? If the answer is no, cross it off. Is 0 plus 0 less than 12? If the answer is yes, leave it in. And now notice, what have you done? You've crossed out 3, which means that whatever remains must be the answer. So you get 4x plus 3y is less than 12. All right, so again, is it dashed or solid? Test, and between those two things, you can get down to the one possibility. Number 14. Graph the solution of the following system. 2x plus 3y greater than or equal to 12, x less than or equal to 3. And we say, okay, use the following. All right. So we'll mark some things here. We have our axes, and so in case you can't see it, we have the y-axis here and the x-axis here. So let's start with the simpler one, x less than or equal to 3. So I come over here to where we have x equals 3. Because it's a inclusive inequality, it's greater than or equal, I'm going to put a solid line, and I want to choose a different color. So here, this is our x equals 3. Now, if I want to have x be less than or equal to 3, which side do I pick? Well, I want the things where x is smaller. So I want to be on this side of the line. So I'm going to use some arrows here just to help me know that I want to be on this side of the line. Okay. Now, next thing. 2x plus 3y greater than or equal to 12. Well, let's start by drawing 2x plus 3y equals 12. And to do that, we say, well, let's find 2 points. Here's the easiest thing to do. Cover up the x. And that's like saying x equals 0. What is y? Well, it tells us it's 3y equals 12. So y equals 4. So you say, great. Count up to 4. So here is 4. That's going to be a point on the line. Now cover up the y. That's y equals 0. 2x equals 12. What is x? 6. So what we're saying here is find the intercepts. So here, there is the second point. So you have the 2 intercepts. Now what do? Connect the dots. Solid line because of greater than or equal to. And so let's see. By the way, during the test, you don't have to make the do sound. That's just mostly me. All right. So there's our line. Now, which side do we want to be on? You can always test. Let's test the origin. Is 0 plus 0 bigger than or equal to 12? It is not. So we don't want to be on the side with the origin, which means we need to be on the other side. And say, okay, now that you've done this, say, all right, what's the region? Well, you're looking for the region where all arrows point in. There's 4 regions. This region, no arrows point in. In these two, only one set of arrows point in, but in this one, both point in. You are not done until what? You have to fill this up. So there's that paint tool that says fill this region up. So make sure you do that. And so our answer for the solution is there. That's what we're after. And also I should point out, make sure you draw these with dotted lines or solid lines according to the inequalities. As we get closer to the end, we tend to almost always use less than or equal to or greater than or equal to. But it's good to make sure. And I probably should have added, just for reference, this is the 2x plus 3y equals 12. And we'll just make some notes. Find intercepts to find 2 points. So that way we can remember what we did. All right. On to number 15. The end is near. Solve the system graphically and indicate whether the solution region is bounded or unbounded. Find the coordinates of each corner point. All right, so we have the following. We want to graph the inequalities. So let's start with the easy two. These are very common. So make sure you account for them. And sometimes, I will note, they just write it in the form x, y greater than or equal to 0. These mean the same thing. So this is just their way of saying both these things are true. So let's start by saying, hey, x is greater than or equal to 0. Well, that says we want to have non-negative x values. So we mark x equals 0 and point towards the positive side. And we say, okay, well, we want to have y greater than or equal to 0. So we say, okay, do the same thing. Here is our y equals 0, and greater than or equal to means we want to go towards sort of in the positive direction. All right, now, the last one. 3x plus y less than or equal to 15. Well, start with the 3x plus y, 5y, plus 5y equals 15, and find the intercepts. If we cover up the x, 5y equals 15, says you come over here to 3. That's where we're going to hit the y-axis. Cover up the y, 3x equals 15, x equals 5, 1, 2, 3, 4, 5. That's where we're hitting the x-axis. We have a solid line. So, okay, solid line. There's our solid line. And now, if 3x plus 5y is less than or equal to 15, we want to be, test the point, 0, 0. 0 plus 0 is less than or equal to 15, so we want to be on the side with the origin. Okay, now, moment of truth. We're not done. We've just drawn the lines, and I'm adding arrows to help me guide to identify what's the right piece. I want something where all the arrows point in. And good news, we have such a thing, this triangle. That is our solution. So when we talk about solving, it's just saying, hey, find where all these inequalities simultaneously hold. Okay, so that's the picture. Now, the solution region, is it bounded or unbounded? The answer is it's bounded. What do we see? Well, if you can draw the whole region on a single page, then it's bounded. It'll sometimes say, there's another way it phrases it, you can enclose the entire region within a circle. But essentially, if you can draw the whole thing, it's bounded. Unbounded says it just keeps going and going and going. It's the Energizer battery of regions, if you will. All right, so that's good. Now, what are the coordinates of each corner point? Type an ordered pair. Use a comma to separate answers as needed. So the corners look like corners. There's 3 of them. It's where lines intersect. And we actually figured it out because we were looking for their intercepts. So we have the origin. Don't forget that. So that's 0, 0, comma. We have up here where the line 3x plus 5y hits the y-axis, and that's at x equals 0, y equals 3, comma. And we have where 3x plus 5y equals 15 hits the x-axis, and that's at x equals 5 and y equals 0. So there are 3 corner points. And there we go. That's our list. Okay, so that's number 15. Done. Good. Good. Number 16. Solve the linear programming problem. Okay, so what makes this a linear programming problem? We're maximizing it. If we covered up the maximum, we say, oh, hey, this is a region in the plane. And it's one of these regions we've been drawing. So that's sometimes called the feasible set. And so it says, hey, among all these points, which one does the best? All right. So how do we proceed? Well, we proceed. I like to do it graphically. And so I'm going to just solve it, and then I'll answer this part down here. So let's do a quick picture here. We have our x and y are both greater than or equal to 0. Notice this time they put them together. And so we'll go ahead and mark things. We have our x greater than or equal to 0. Here's x equals 0. And just putting in. We have our y greater than or equal to 0. And so we say, okay, pointing up. Very common. Basically it just says, hey, you're staying in the first quadrant. These are very common assumptions because oftentimes these problems arise where x and y represent things which can't be negative. Like I can't unbuild something. I can't, have negative time. There's just the quantities they represent just have to be non-negative. So these are ones you just anticipate them being there. All right, now we have 2 other lines. So let's just do them. 2x plus y equals 24. And I'm just going to mark the intercepts. I'm not going to try to overthink these. And so I have 24. That's where I'm going to hit the y-axis because I put in x equals 0. And then I have 12. That's where I'm going to hit the x-axis. And I'm going to go down. Okay. Think about the origin. Is 0 less than or equal to 24? Yes. So I want to make sure I am pointing to the side with the origin. All right. Now, I have another line. X plus 2y less than or equal to 18. Say, okay, let's mark this. Well, look for the intercept. Where does 2y equal 18? 9. Right? Just cover up the x and solve for y. All right, cover up the y. And where do we get? We get 18, which is over here. Now, see, like I can order 24 versus 9 and 12 versus 18. And so we say, okay, so then we have this line. Say, all right, what do we need here? Well, we need 0 plus 0 less than or equal to 18. We're pointing down. All right. And now we stare at this and say, all right, among all these pieces, because there's a lot of pieces here, because every time we cut, we essentially make a lot of new pieces. What's the piece we're after? Frequently, it's this bottom left corner. Very frequently. Not always, but very frequently. especially if you see things where you have x, y greater than or equal to 0, and then everything else looks like positive coefficients less or equal to number. So that's our region. Okay, cool. So amongst all the points that we could have a maximum, it's a point in here. But you're probably saying, but Steve, that's a lot of points. Here's the secret. And I'll tell you because we're friends. We don't need to test all the points. What do we need to do? Check the corners. Once we know we're bounded, we know for sure we can find a solution, and we also know for sure it's going to be at a corner point. Now, 3 of our corners are going to be easy. The origin, that's pretty easy to find that. Here, this is the x-intercept, and that's at 12, 0. Okay, that's all good. Here, y-intercept, 0, 9. Cool, cool, cool. And then there's one more. How do we find that? Well, we have to work through it. So we have to find the intersection of 2 lines. So we have the 2 lines, 2x plus y is equal to 24, and x plus 2y is equal to 18. Well, all right, if we subtract, well, let's suppose, what do we want to get rid of? Let's suppose we want to get rid of the x's. So I'm going to multiply by -2 times the second equation and add it to the first equation. So this is elimination by addition. 2x subtract 2x is 0. Y subtract 4y is minus 3y. 24 subtract 36 is minus 12. That gets us to y equals 4. Okay, suppose we know y equals 4. Plug it in. 2x plus 4 equals 24. Or 2x equals 20. Or x equals 10. So the intersection of those lines happens at 10, 4. All right, there we go. Now, that's our corner. What can we do? Well, now that we have our corner, and by the way, it's not bad to check, right? 2 times 10 is 20, plus 4, 24. Good. 10 plus 2 times 4, 10 plus 8, that's 18. Good. Now what we do is we compute this 3x plus 3y. So these are x, y's. 3 times 0 plus 3 times 0 is 0. 3 times 12 plus 3 times 0, 36. 3 times 0 plus 3 times 9, 27. 3 times 10, 30. 3 times 4, 12. And that makes 30 plus 12, 42. And we've made our region. We found our corners. We listed our corners. We tested our corners. Our last thing is to celebrate the answer. We scan the numbers and say, hey, what's a big number? 42. That's our biggest number. That is the solution. This is the maximum value. This is the location where it happens. Now we've solved. Let's see what we're supposed to have done. Hopefully it's helpful. All right, select the correct choice below and fill in any answer boxes present in your choice. Where is the maximum value of P? Okay, so what is the maximum value? 42. So we say, great. The answer is 42, and it's A. By the way, as soon as you know it's bounded, you can eliminate there is no maximum. anything that's bounded has to have a maximum. Okay, next part. Select the correct choice below and fill in any answer boxes present in your choice. What are the coordinates of the corner point where the maximum value of P occurs? Well, that's at that corner. And notice they even told us right there. So even if we forgot, oh wait, what do? It's present in the answer. So the coordinates are 10, 4. It's possible in very unusual circumstances that you might have two corners being a maximum, but it's very rare. And so I highly doubt you'll see that. So don't stress about that. All right, that leaves us with our last problem, which is going to feel very deja vu-y because it's almost the same thing. Solve the linear programming problem. And everything looks the same. So what are we going to do? The same thing. So we just are going to be patient and work through the process. And what makes this one a little bit more challenging is we have more constraints. And as soon as you add more constraints, you have to be a little bit more careful with your picture, especially since they didn't actually give us something to work with. So let's make sure we're being careful with our picture here. All right, so we have our x is greater than or equal to 0 and our y is greater than or equal to 0. And so we're used to that, hopefully by now. Okay, so we know we want to be in the first quadrant. All right, no big surprises there. And we know we're above the x-axis to the right of the y-axis. All right. Let's sketch these pieces. 2x plus y less than or equal to 16. And where do we hit? We start at 16. And we're going to end at x equals 8. So 16, 8. And 0 plus 0 is less than or equal to 16, so we want to be below. Okay. X plus y less than or equal to 10. Now, say, okay, well, where is 10? Well, okay, between 16 and 10. 0 and 16, 10 is roughly here. 8 and 10, a little bit further over 10. And I'm going to choose a slightly different color. So, right, because y equals 10, x equals 10. That one's a pretty clean one to draw. So we have this line going through the tens. Okay. 0 plus 0 is less than or equal to 10, so we're again heading down. We're going down. One thing that can help you is you can always just sort of think of, hey, with my first condition, x greater than or equal to 0, I know I'm up here. Add my second condition, y greater than or equal to 0, that cuts it down. Now we're in this piece. Then we say, okay, draw the first line. Oh, now I'm in this triangle. Draw the second line. Oh, now I'm in this part. Right? You can just recursively keep cutting away, because that's what's going on, is you're cutting away. And until what you're left with. So we know we're going to be a piece in here. And we're just slowly working our way through it. So for our last thing, let's see, what do we have? We have x plus 2y less than or equal to 17. Oh my goodness. Okay, well, that's all right. Where do we hit? 17 divided by 2, that's 8.5. Okay, so, okay, running out of colors. 8.5. And then x equals 17. It's way over here. So what's going to happen? Well, we're going to go very slowly in that direction. Now, this is where the picture can get a bit muddled. And so it's not too hard to figure out. We want to go below here. It's not too hard to figure out, hey, that's a good corner, that's a good corner, that's a good corner. But then you kind of have these other three, the intersection of those pairs of lines. And you're like, which ones of those are corners? Do I have one corner, or two corners, or three corners? How do you know? So there is a method, and I'm going to talk about it really quick, which is to say, test all the intersections. If you aren't sure, check them all. And because it's better to be sure. So we're going to list our points. We have what? 2x plus y equals 16, and x plus y equals 10. Okay, so I'm going to start with these two equations. And we say, okay, well, we'll do elimination. And what happens? We get 2x minus x is x. 16 minus 10 is 6. So that says, okay, x equals 6. Once you know x equals 6, you say, okay, well, plug it in. 6 plus y equals 10. And so that says y equals 4. So one candidate for a corner is 6, 4. I call it candidate. It's not a corner yet. And I'm going to get to how we move from candidate to actually corner in this messy part where they overlap. Okay, now let's do the last pair. 2x plus y equals 16, and x plus 2y equals 17. It's going to get messy, and I do apologize. Subtract 2, and 2x subtract 2x is 0. That's good. Y subtract 4y is minus 3y, and 16 subtract 34 is a number. It's negative 18. So what does that give us? Well, that tells us that y equals 6. Okay, now that we know y equals 6, we plug in. And we say, well, okay, x plus 12 equals 17. So that gives us x equals 5. And so this is at the point 5, 6. All right, that's another candidate. And then there's a third candidate, which is x plus y and x plus 2y. So we have the x plus y equals 10, and the x plus 2y equals 17. Okay, looking for intersections. Well, we can minus the first one from the second one. If we do that, what do we get? Well, we get minus x plus x is 0, minus y plus 2y is y, minus 10 plus 17 is 7. So we say, okay, that gives us y equals 7. Plug it in. X plus 7 equals 10. So that tells us x equals 3. So we get 3, 7. All right. So if we don't have a good picture available, we can always find where they intersect. Now, we have our corner list. And we say, well, let's write these down. And we have 0, 0. We have this 17 halves, which, remember, it came from here. And that's at 0, 17 halves. And then we have this 8, 0. Now, these are other potential corners. What do? You just check if they satisfy all the inequalities. Now, here's the easy thing. You see how we used the 2x plus y and the x plus y? That's automatic. Check the last one. Does 6 plus 2 times 4, 8, is that less than or equal to 17? It is. So that is a corner. So 6, 4 is a corner. How about 5, 6? Well, it came from 2x plus y and x plus 2y. And what happens? Well, if we add 5 plus 6, is 5 plus 6 less than or equal to 11? It is not. So what that says is that, like, that's this intersection. It's outside of our region. So anything which could be a potential corner, you can always just plug in and say, does it satisfy the inequalities? The last one, 3, 7. Well, for that, we say what? Well, we definitely satisfy the x plus y less than or equal to 10. We definitely satisfy x plus 2y less than or equal to 17. We definitely satisfy x and y greater than or equal to 0. Check the last piece. Is 2 times 3, which is 6, plus 7, is that less than or equal to 16? The answer? No. I don't think so. Oh, wait. Yes. I can do math. Sorry. That's 6 plus 7. That's 13. 13 is less than or equal to 16. So that is a corner. Okay, good. Okay, sometimes it takes a bit of work. All right. Well, now that you have the corners, plug in to 20x plus 15y. 0 plus 0, 0. 0 plus 17 halves times 15 halves. Well, okay, that's a number. It's 200 and all right. I have a calculator here. I don't have to. Well, I maybe have a calculator here. 15 times 17. 255 over 2. Okay. And just for reference, that's 127.5. All right. 8, 0. That's 20 times 8 is 160 plus 0. So that's 160. 20 times 6 is 120. 15 times 4 is 60. 120 plus 60, 180. 20 times 3 is 60. 15 times 7 is 105. 60 plus 105 is 165. Now, we're basically done with the work. We read through this and say, since we're maximizing, what's the biggest number? The 180. So, here we go. What is the maximum value of p? Well, it's a bounded region. In fact, even after we just those three inequalities, just these three, that bounds our region. So we definitely know it's a bounded region. So b is out. So what's the largest value for p? It is 180. What are the coordinates of the corner point where the maximum value of p occurs? So first off, we should circle A. Did we do that on our previous problem? We forgot to circle A on our previous problem. We want to get the points. Come on. Get the points. Get the points. And the coordinates are what? 6, 4. All right. Done. Oh. Now, let's talk about some things. Let's be honest. You're looking down at the time, and you're like, Steve, we don't have that much time. How am I supposed to do this? Good news. I went really slow. You can go faster. So that's one thing. Other good news. You can be smart about your time. Learn time management. There were basically 3 problems that slowed us down a lot. Finding the inverse of a 3 by 3, and the last 2 problems about solving a linear program. Spoiler alert, all problems are worth the same. So save those 3 for the end. get the other points first and then go for the harder ones. Or maybe we won't have to do two linear programs. That would be great if that was the case. But I would say if you're smart with your time, you should be fine. And be careful, be patient, but work methodically. You can do this. We believe in you. Good luck, and I hope you do well. All right. Bye.